the previous lecture we have talked about the Kirchhoff voltage rule and Kirchhoff current rule, that is KCL and KVL, and we have learnt about that how these are applied in the closed circuit or in a mesh or in a loop. Now based on this law we should solve some problem to clear our understanding. So for example, in this case, find current in different branches of the electric circuit shown in the figure. Here figure is shown and we have to find the current in different branch. For example, for here it is 6 volt cell is given, and it is a 2 ohm 4 ohm resistor. Again it is a 4 volt 4 volt cell, and it is a 2 volt cell. This resistor is 2 ohm and this resistor is 4 ohm. Now to solve this problem, first let KCL, that is Kirchhoff's current rule, applying at point B. Here if first we have fixed a current I1 which is flowing in this direction. Again it at this point it is divided into two parts. I3 is flown in this circuit and I2 in this circuit. Again it combined at point, and this loop is I1. So at applying KVL at point B, it will be I1 equal to I2 plus I3. This is question 1. Now KVL in loop ABFA, applying KVL, that is Kirchhoff voltage rule, in this loop, and we are going along this direction. Now because we are going at higher minus at this point, starting from this point, because current flows from higher to lower potential, so this is low and this is high, so low minus I will give negative, so minus 4I1, I into R, voltage is given by I voltage, so I1 into minus 4 will be the potential difference across this resistor. Now going in this circuit, I2 is flowing, but this point is at higher potential and this is at lower, so higher minus lower will be equal to positive, so it will be plus 4 because EMF of cell is given 4. Again in this lower minus higher negative, so minus 2I1. Again this will be positive because higher minus lower positive, so plus 2 equal to 0. Now in loop KVL is completed. So from solving this we get minus 6I1 plus 6 equal to 0. This implies I1 equal to 6 by 6, 1 ampere. Question 2. Again applying KVL, Kirchhoff's voltage rule in loop BCDEB, we are going in this. This is at higher, this is at lower, so lower minus higher will be negative, so minus 2 into I3, minus 2I3. Here this is lower and this is higher, so lower minus higher, minus 6 volt, minus 6. And at this point again final is at lower and initial is at higher, so final minus initial give that is lower minus higher equal to negative, so minus 4I3 4I3 because current in this branch is I3. Again in going this direction, lower minus higher negative, so minus 4 equal to 0. From this we see that minus 6I3, whereas minus of I3 4I3 and minus of 2I3 will be minus 6I3, minus 10 equal to 0. This implies I3 equal to minus 10 by 6 equals to minus 5 by 3 ampere. Now in this case negative sign indicates that direction of current is opposite to the assumed direction. Whenever we get the negative value of current, we have to consider finally we have to take the current direction opposite to the negative assumed direction. Now using 2 and 3 in one, we get I1 equal to I2 plus I3. This implies I2 equal to I2 minus I3. 1 minus minus of 5 with 3 equal to 1 plus 5 by 3 equal to 8 by 3 ampere answer. So here we see that how can we solve the a closed circuit problem by applying KVL and KCL, and we know about the rule how to apply these KVL and KCL. So we can solve any type of problem applying these rules. Next, our next topic is voltage drop. Voltage drop. When we move from higher potential to lower potential in a resistor, then voltage drops and is given by VA minus IR equal to V. For example, at this point, this is a resistor and current is flowing in this resistor in this direction. It means that it is at higher potential, is it at lower potential? B is at lower potential. So we can write VA, potential at A, VA minus this value is drop going in this direction. So minus IR equals to VB. Because this is at a higher, so we have to remove some voltage so that it become equal to VB. So this value is removed and it will be equals to VB. So VA minus VB equal to IR. Here VA minus IR equal to VB, so VA minus VB will be equal to IR. Second case, in cell when we move from positive plate to negative plate, then voltage is dropped. In the case of cell, if we move from positive plate to negative plate or positive terminal to negative terminal, then voltage will be dropped. For example, here in this case VA, it is at a higher potential, it is at lower potential. That is, this is at a higher potential, this is at lower potential. So we can write if point A is VA minus E dropped, this value is dropped equal to VB, because because it is a lower potential, then and it is higher potential, there's some value of volt has been to be minus. So this value is E, we have to minus E so that it become equal to VB. So VA minus E equals to VB. So VA minus VB equals to E, EMF of the cell. Now in the case of charging and discharging. Charging and discharging based on this concept. Here it is the case of charging. For example, current is flowing in this direction. There is a current is flowing toward the positive plate of cell. Now we know that it is at higher potential and it is at lower potential. Negative terminal is at lower potential. This is the internal resistance if you consider. So we can write VA, that is potential at of this point VA, or this point may be at this here. So VA minus when we go in this direction, because it is at lower and it is at higher, so this should be minus. So this potential across this should be minus. So minus E, again we are going in this direction, higher to lower. So again this will be minus IR equals to VB. It means that if we subtract potential across EMF and potential across resistance, then we'll get the voltage equal to B, that is VA. We have to subtract potential of this and this from VA, and that will be equal to B. So VA minus E minus IR equal to VB. This implies VA minus VB equal to E plus IR, case of charging. As earlier we have discussed, in the case of charging, the terminal voltage, that is potential across the battery, is equal to E plus IR, where R is the internal resistance of the cell or battery. Now in the case of discharging, that is current coming out from the positive terminal of the battery or positive plate of the battery. So in this case current is flowing through in this direction. Now again we can write potential at A, we are going to the toward the lower potential, so we have to minus it, so minus E, plus in this case we are going from lower to higher, So this will be positive. So plus IR, because higher minus lower will be positive. So we have add up positive IR equals to VV. VV. So in this case, VA minus VV is equal to E minus IR, case of discharging. We have found this value in the case of discharging. In both cases, if circuit is open, then I equal to 0, and VA minus VB will be equal to E, which is required. That is EMF of the terminal voltage will be equal to the EMF of cell when circuit is open. In this case, we have considered that circuit is closed, that is it is connected with some another source of battery. Here it is also connected with another source of battery which is not shown. If current, if this whenever we show the current flowing in the circuit, it means that it is connected with another source. It is a part of circuit. Our next topic is voltage rise. Voltage rise, this is the reverse case of a voltage drop. Case 1, when we move from lower potential to higher potential in a resistor, then voltage rises. For example, current is flowing in this circuit in this direction, and this is a resistance of resistor of resistance R. Now if we go from this direction, that is it is at, because current is flowing from in this direction to this direction, so this point will be at lower potential. So we have to add this voltage to make it equal to VB. So VA plus IR will be equal to VB, because higher minus lower will be positive, so we had added positive value. So VA plus IR equal to VB. This is called voltage rise, because we are going from one point to another point. The voltage is rising. That is, this voltage is at higher potential, and this voltage is at lower. VA plus IR equal to VB. Second scale, in cell, when we move from negative plate to positive plate, then voltage rises. We know that the negative plate is at lower potential and positive plate is at higher potential. So we can write VA, and we have to add or minus this potential. So because we are going from lower to higher, so higher minus lower will be positive, so we have positive value equals to VB. So VA plus E equals to VB, so VA minus VB equals to E. Now charging and discharging. Here this is the case of discharging. Again we applying VA minus IR plus E equal to VB from the above rules. So VA minus VB equals to minus E plus IR, or VB minus VA, or VB minus VA equal to E minus IR. Discharging, this is the case of discharging. And case of charging, that is, this is point A and current is flowing from negative terminal. Here current is flowing from positive terminal, opposite of this case. So in this case, if we write this is at a higher potential, so VA plus IR, and again it is IR plus E equal to VB. So we have written VA plus IR plus E equal to VB. This implies VA minus VB equal to minus of E minus IR, or VB minus VA equal to E plus IR. So we have to see the point, and we have to see the current, in which direction current is flowing, and then we have to decide. In case of resistor, we have to decide the lower potential side or higher potential side. Again in cell, we have to decide which plate is at higher. In cell, positive plate is always at higher potential, and negative plate is always at lower potential. So we have to use this concept in solving the problem. Now based on this concept, we will see some problem. In this case, for example, Find VAB, VBC, VCD, VDE, VBE, VEP, VEF. It means that we have to find the potential difference between A and B point, that is VA minus VB, VB minus VC, VC minus, similarly for all value. In the previous problem, we have, for example, in this VAB, we have to find VAB. So we can write VA, because we are going from higher to lower, so VA minus 4 into I1 equals to VB. Here it is shown in the circuit, that is VA minus 4 I1 equal to VB. So VA minus VB equal to 4 I1, or 4 into 1 equal to 4 volt. So potential drop across there is potential difference between point A and B is about 4 volt. Similarly, for BC, where current is in this direction, again we can find potential difference between B and C. So VB, and we are going from lower minus I, so will be negative, the 2 into I2, because potential drop across resistance is equal to the resistance to current, so 2 into I3 equal to VC, this will be equal to this. So VB minus VC will be 2I3 equal to 2 into minus 5/3, or VB minus VC equal to minus 10/3 volt. Negative sign indicates that VB is at lower potential. It means that VB is at lower potential, not C is at lower potential. If in the answer we get a negative value of our assumed value, this we have to consider opposite sense. Next, in C to D, again we can write VC, now going from higher to lower. So this is at lower, this is at higher, final is lower and initial is higher. So final minus initial is here negative, so VC minus 6 equals to VD, and so this implies VC minus VD equal to 6 volt. Again in this 4, we are current is flowing in this direction, and current always flows from higher to lower. So in this case, this point is at higher and this point is at lower. So we can write VE plus I3 into 4 equal to, or we can take from this direction. If we go from this, we can take from any direction. There will be no difference in the result. For here, for example, we are going from in this direction. So VD, now going from lower to higher, we are moving in the current direction. So we are going at lower potential and higher potential. So lower minus higher will be negative. So VD minus I3 into 4 equal to VE. So VD minus VE will be 4I3, or equal to 4 into minus 5/3, or equals to minus 20/3 volt. Again here negative value shows that our assumed potential will be opposite, that is opposite to assumed value. For example, in this case, because the VD minus VF has come negative, so VD will be at lower potential and E will be at a higher potential. Next, VB. Again we have to find a VB. Now we have to move from this to this direction. Now this is at positive potential, this is at negative potential, and this is positive terminal, this is negative terminal. Positive potential is at higher positive terminal is at a higher potential, and negative terminal is negative plate is at lower potential. So final we are going from initial to final, because we are moving in this direction, because we have to find VB, that is VB minus VE. The VB final is higher, initial is lower, so final minus initial will be positive. So VB plus 4 equals to V, so VB minus V equals to minus 4 volt. Answer. So our assumed direction VB minus V4, negative sign shows that this is not at higher, VB is not at higher potential, VB is at a lower potential. Next, we have to find VEF. So we have to go from in this direction. The VE. Now again from higher to lower. So lower minus higher will be negative. So VE minus I1 into 2 equal to VF. So VE minus VF equal to 2I1. 2 into 1 equal to 2 volt. In this case, because we have find positive value, so our sense is right. So E will be at higher potential and F will be at lower potential. So V minus V, we have come out to be positive. This is true. Its direction sense is true. Now VFA, we have to go from this side to this side. So here we are going in this direction. Now this is only cell. So here we have to consider, because it is negative plate, so it will be lower potential, and it is positive plate, so it will be higher potential. So final minus initial will be positive. So Vf plus 2 equal to Va. So Vf minus Va will be minus 2. Again here we get negative values. So our assumed potential is opposite. That is Vf is at lower potential and Va is at a higher potential.